G'day guys. So, as you'll all remember, we did this practice test in class. So I'm going to go through that all as quickly as I can. Feel free to jump ahead to the question you want to look at, pause, all that good stuff. It is a video after all, okay? Let's see, this first one here, definitely a hard one, okay? Bear in mind that I am going to be trying to do these on the quick side here. The brackets around the y to the negative 10, there's nothing, being applied to them. There's nothing added, minus, whatever. So they're not actually doing anything. We can get rid of them. Inside here, that 3 is to the power of 1, that y is to the power of 2. When separated by a bracket with the power outside, we multiply. So we get 3 to the 1 times 3, which is 3 to the 3. Then we get y to the 2 times 3, which is y to the 6. And that's all over 9y. Simplifying here, we have y to the negative 10 times x to the y to the 6. Remember when we have, if we look at our index laws, this is index law number 1 over here, where same base, we can add the powers. So here, I'm essentially doing y to the negative 10 plus 6, right, which you guys will be able to work out is negative 4. Still times that 3 to the power of 3, still over 9y. Remember that y by itself is 9 to the 1.
What are you doing?
All right, sorry, I got interrupted there by Mr. Hudson. As I was saying, we've got the fraction here, which is the second law there. Remember, fractions mean divide, so this could also have been written as a to the m over a to the n, and you still get it where you subtract the powers. So coming back here, we have y to the negative 4 over y to the 1, so we'll get y to the negative 4 minus, well, that's supposed to be a 1, y to the negative 4 minus 1, which hopefully you guys can work out is going to be y to the negative 5. 3 to the power of 3, remember, means 3 times 3. Oh, I have not written that well, hang on. Remember, means 3 times 3 times 3, which you guys, if you put it in the calculator or if you do it in your head, either's fine, you'll work out that that equals 27. So this bit here, just because I'm running out of space, just going to rub that one out. It's actually 27. 27 divided by 9, because 9's on the bottom of the fraction. 27 divided by 9. 9 goes into 27, or 9, 18, then 27, 3 times. Okay, so we end up, that 27 divided by 9 is 3, so we get 3y to the negative 5. Cool. All right, definitely a hard one, that one. All right, next one here. Remember this a here is to the power of 1, and then when we have the brackets, we're going to be multiplying the powers in, so we're going to end up with a to the 10, b to the, not 10, sorry. We're doing 5 times 10, right? So first it was 1 times 10, now we're doing 5 times 10 for the b, so we get 50 divided by a to the 5 times 7, so we end up with a to the 35, and then b to the 3 times 7, so 21. Now remember, this was all in brackets here, so we're going to keep that in brackets. And this is all in brackets here, so I'm just going to focus on the a terms first. So a to the 10 divided by a to the 35. Remember, divide means minus, so we're going to get a to the negative 25, and then b to the 50, and then, sorry, that was, 10 minus 25 in the powers for that first one there. And then b to the 50 divided by b to the 21. We're going to get b to the, what's going to be 50 minus 21, which should be 29. All right, I'm sure you guys will let me know if I got that wrong. And that is my answer. Okay, sorry, I got interrupted by Mr. Hudson a couple times again, if I paused. All right, this one over here. This one is going to be another one of our laws. Which one is it? There it is, that one over there. So it says that when we have a negative power, you guys remember the analogy I've been using in classes, that it's almost like a little ticket, and we use that ticket to go below the fraction. So coming back here, below the fraction, we've used the ticket, so it's now positive. We get 1 over 3 to the 5. That's it. If we started on the bottom, though, and we wanted to move to the top, we can do that too. Right? Still using the ticket, it still becomes positive when it moves to the other side of the fraction. All right, on to some harder ones now. Same story, this a is to the power 1, and this 10 is on the outside of brackets, which means we're going to be multiplying. So a to the 1 times 10, a to the 10, b to the 5 times 10, b to the 50, a to the 5 times 7, a to the 35, b to the 3 times 7, b to the 21. Okay, remember this is all this law here, where it says that everything inside the brackets gets the power multiplied inside them. So we did 10 times 1 to get 10, 10 times 5 to get 50, 7 times 3 to get 21, and 7 times 5 to get 35. All right. Now we look at the same bases. So A and A have the same bases, which means that we're going to have A to the power of, that's right, different color. A to the power of 10 plus 35, or 45, times B to the power of, what's 50 plus 21? 71. All right, so remember just there when we're adding the powers, we're coming back to and using this first law again. All right, cool, making good progress. Similarly here, we got the same bases, so we can just add these powers. So we get 4 to the negative 7 plus negative 3. If you look at the number line in the classroom, start at negative 7, and then instead of going forward, right, because normally plussing you'd go forward, but we're plussing a negative, so we're going to go backwards 3 spots, we'd end up with 4 to the negative 10. Of course, if you don't believe me, check your calculator. Okay. This one here, expanding brackets, we do x times x to get x squared, x times 6 to get plus 6x. This one here, we do negative 3 times x to get negative 3x squared, negative 3x times negative 5 to get plus 15x. Okay. One little note here too, because we did the negative times negative to get the positive. If you haven't got it in your notes already, this is probably a good thing to, add, which I feel like I didn't really emphasize enough in class. So like positive times a positive is positive. Negative times a negative is a negative. Negative times, that's a positive. That was a horrible mistake of me. Negative times a positive, that's a negative. And positive times a negative, that's also going to be a negative. Easiest way to remember this is that when you have a matching pair, so notice how like plus and plus, negative and negative are matching, you get positives. Whereas when they're not matching, we end up with these negatives, right? Because we have a mix of a negative and a positive in both cases there. Okay. All right, next one. We've got 3y plus y times 4 plus y. Only the y is being multiplied by those brackets. BIMDAS tells us that we do the multiplying first. So this bit here, I'm actually just going to straight up ignore for a bit because we do the addition last, all right? So y times 4, that's 4y. Y times y, that's y squared. 3y's at the start. Now we can collect the like terms. 3y plus 4y, well, that's 7y. Can we collect the y squared? No, we can't. It is a different term, okay? All right, this one here, we're coming back to our index laws. This one isn't really listed here, but it's kind of like this law here. We'd have a over b instead of a times b, and that's to a power, and then everything gets that power, okay? So similar thing's going to happen over here. We're going to get, so that x to the power 1, so we're going to get x to the power of 3, because 3 times 1 is 3, over 2 to the 4 times 3, 4 times 3 is 12. Whole question, done. All right, on to the hard ones, or so to speak. Perimeter, we just start by putting the formula in. Then I'm going to call this side here the length, and this side here the width, which means instead of the length, I'm going to put 2x minus 3, and instead of the width, I'm going to put 4. Using my expanding brackets, 2 times 2x is 4x, 2 times negative 3 is negative 6, and then here 2 times 4 is just 8, right? Negative 6 plus 8, well, that's plus 2. All right, you can check that on your calculator. 2 and 4x, they're not like terms, we can't collect them. Hypothetically, I know this question doesn't say it, if this had said like meters, right, 4 meters, 2x minus 3 meters, this would be 4x plus 2 meters. All right, let's keep moving. When we get this done quick, area equals length times width, right, just reciting the formula. We already said this is the same rectangle, right? We already said that the length is going to be this side here. So I'm going to put that in for L, 2x minus 3. And that's times the width, which is going to be 4. Same way that 2 times 5 equals 10 and 5 times 2 equals 10. I can say that this is 4 times this stuff here, right? It means the same thing. Just changing the order we multiply doesn't affect anything. Now we're expanding. 4 times 2x is 8x. 4 times -3, -12. Whole question, done. Keep it moving. All right, this one here is a little bit harder. And admittedly, I haven't done this one yet, so you guys are going to be working together with me through it. So you'll get to hear a lot more. I think it'll probably be a bit slower. All right. We have 2 areas. Now, I don't know yet if I want to break them up so that it's like that, or if I want to break them up so that it's like that. I think my gut says we're going to do it like this, but I'm not sure yet. Okay, so let's have a look. We know the dimensions of if this here was our first rectangle. We know this width, so to speak. We don't know this length. And then similarly here, if I had this rectangle over here, I can see here at the moment I've got this length, but I don't know this width. So is there some ways we can work that out? There is actually. If I'm looking from top to bottom here, right, it's given in the question that that's x. And then if I'm looking at just this little bit over here, actually let's change color again, green. If I'm just looking at this bit here, right, just, roughly that's about that much there. We've said that this is x minus 2. Okay, so this whole distance here was x, and then this little bit here was x, right, that whole distance there in blue, subtract 2. So I took off 2. And I've taken off, you guys would probably agree, that from the original thing there, I've taken off about that much there, i.e. the distance from here to here. Taken off about that much there, and so if I started with x, and ended up with x minus 2, well, I took off 2. This bit's just 2, right, which remember we said is this bit here, right, that we've used the question mark for. So that length there is 2. Sweet. All right, I've got another dimension. Now I need to work out this one down the bottom here. So we're going to do a similar analysis. We can see that from left to right, that whole thing is going to be x plus 5. All right, and then just this little bit here, let's find ourselves another color, just this little bit here, which let's call it that bit for there, is 3. And we're interested in this last little bit here with the question mark. So if we had, let's just go to red for argument's sake. So if we had 3 before, 3 for that little bit there, and all together makes x plus 5, would you agree that that's x plus 2? Does the x plus 2 plus 3 give us x plus 5? Yes, it does, right? Which means this side over here that we didn't know the length to is actually x plus 2. Okay. Now look, this is going to keep getting a little bit harder, so we're going to keep going, keep persevering. Next up, we've got got to break this up into 2 questions. So we've got area 1 and we've got area 2. Area 1 is equal to length times width, and remember I called this bit here the length, right? So we're going to put that in for length, x plus 5, and then we've got this bit here for width, so times 2. All right, expanding that out, we get 2x plus 10. All right, that was the easy one. Area 2, we've got length times width. We're going to end up with the length, which we said was x plus 2, times the width, which is x minus 2. Now, admittedly, this is a little bit outside the scope of what you guys need to know for this test. All right, so we're getting a little bit harder now, but we'll keep going. So we have x, we have what's called double brackets. So every single other question we've done where we're expanding it, we only have the one bracket, right? Whereas this one here, I've ended up with a bracket times a bracket. So look, I'm going to spare the teaching for another time. We quite literally just do x times x to give us x squared. Then we do x times -2 minus 2x. Then we do 2 times x plus 2x and 2 times -2 minus 4. All right, I know I'm going quick. X squared minus 2x plus 2x. So minus 2 apples plus 2 apples, that's 0, right? This bit here just equals 0. So that actually disappears. We just end up with x squared minus 4. And that is going to be area 2. We're not done, right? Because we want the area of the whole thing. So we found the area that we found here gives us this top shape. The area that we found here gives us this bottom shape. We now need to add that together. So the total area is going to be 2x plus 10 plus x squared minus 4. We end up with x squared, just collecting like terms because the brackets aren't doing anything here. Not too sure where I put them, to be honest. And then we get plus 2x. We've got plus 10 minus 4. 10 minus 4 is 6. Okay. That is going to be my final answer. All right. Thanks for listening, guys.